I'd like to tell you about Linux Switchdev, what this is about and how we are living with that. We're using Switchdev with Mellanox curator, and they are attributable to white box switches, so it means that you can install different operational systems on that commutator, and usually the vendor would offer certain SDK for that, and switch abstraction interface to interact with the commutator. There is an operational system from Mellanox, and it's been supported by SAI, some common languages for different commutators. They have Sonic, and it's been supported by Sonic Switchdev. Switchdev is a kind of infrastructure in kernel infrastructure, which helps you to display the in-kernel infrastructure and install that on the hardware of your commutator. And on this slide, you may see that pink stands for the commutator, blue stands for the AP, and utilize for setting of the user interface. Yes, Switchdev is the mediator between user space and the kernel, and it provides infrastructure for the kernel to display that. Mellanox commutators are using a standard set of functions, so routers, HCP, etc. So these all things have been supported. And you may offload the data plane. That we are liking policy-based routing. So there is no support of the offload. Mellanox driver may be found in the vanilla kernel version, so you don't need any patches or any drivers. You may take the kernel from your distribution or compile that yourself. So the features are updated by the driver itself. In order to tune the switch itself, certainly we use certain utilized standard ones available from Linux Toolkit, HTool, LLDP, QoS, and Sysctl for certain parameters. For VRF, Linux has their network expresses, and there is a subsystem of VRF which is different from the rest of the system. Your interface is allocated in one X space. So in case you're working with the VRF, in order to manage the routing, you have to develop a special rule, IP rule, which defines what VRF this or that package is attributable to, and actually it would send that to a special routing tab. Special interface, VRF interface would be set up, and the tab would be connected to that, or pegged to that, or linked to that. If you want to add one more interface to your VRF, by means of an IP link, you will set master for your interface. So how, as far as these interfaces are located in the same environment, there is an opportunity. You may indicate a route from a different VRF and provide for the communication. For instance, we have the following issue. We get traffic from sublink and would like to direct that to some filtering nodes. In Cisco, we would develop an IP policy roadmap, or we would set the next hop. In Linux, actually, it is not all reduced to IP rule, and we made the following thing. We have divided the VRF into two parts. In one part you may find some external interface, and in the other part you may find the interface with our filtering nodes. This is how it all links. This is how the routing looks like. In the internal VRF, actually, you have a standardized route, domestic routes and default route from our link. And in the outside, external VRF, actually, you may find the filtering nodes. So it's kind of a pseudo or quasi router. In general, when you are configuring your commutator, you have to set the ports, then you set the bond, then bridges, then VLAN, loopback, addresses, and the routes. Usually it's been driven by the very structure of the interfaces, where there might be more restrictions. That's a very boring piece of labor. Before we had a big script which would set these things, but sometimes we have to introduce some runtime changes. And this causes pain because you have to actually disassemble that starting from the interface, and this is pregnant with mistakes, fraught with mistakes. You change something and the environment would take care of that, and this is a low-tier work being done. But luckily we have Perl, and we have designed a router, and it is being used in order to generate the instructions to set the network. And also we support the changes. So once actually certain pushes are being made, you may have a look at what can be done in order to bring that in compliance with your desire, with your intent. Initially, once you launch that configuration, so the system will generate this set of commands. And they might be different commands, but if you are not using that script, then actually it can be supported. For instance, once you have to take one port and switch that to another bond, then you have to switch this port off the previous bond, and the bond has to be disconnected from the bridge. Then actually the bridge has to be changed, and the bond has to be reconnected to another bridge, and it's very boring to be done manually, and the script does that on its own. Next. ACL, which you have to set on your own. APL actually is being used for filtering. If you actually want to do the filtering in TC, you have to use special switch filters. You have to bear in mind that these filters actually are going to filter not the routed traffic, but also the one which is commuted. And actually it can be connected only to the physical ports. If you're working with VLAN, then more sophisticated approaches are needed. And there are some very interesting features. For instance, you may put a block on top of your interface on several interfaces, and they would share common filter. There is a go-to operator, which is quite good. And you may do some linear connections. We have a special Utilize XSL. We mainly are working with VLAN at such a tier, at such a level. And for every VLAN, it creates its own chain. And in the main line, it would match the VLAN and would move to another chain. This is a case of such a configuration. And as a result, we get such commands. They are less in number than a case of configuration, because one rule stands for one command. But if you have to introduce certain changes, then there is another utility which makes sure that all the changes are being redone, especially the ones which are amended or changed, and the enumeration would change so that the reference is made to the new chain. Obviously, if you do that manually, then it would be enough to write one command, but for that you actually have to look at the current state. And this is how TC filter looks like. And it's very difficult to work with it. You're working with it and people would just pass by and looking askew at you. ACL filter was the first to be developed by us because actually it was much easier for us to start working with that. This utility is published in the public domain, so it's free. You may use MIT license with no guarantee, certainly no warranty, and you will get a couple of scripts, quite little scripts with no dependence, so they are using a couple of per modules, and Linux utilities are to be used. And finally, for those who have some experience of working with serial console tips, if you think that this is actually a way out of Vim, that's true. This is a command for BIOS which actually equals Control Alt Delete. For instance, if the computer has frozen, you can take advantage of that. And, your kernel has to be controlled from another space, otherwise it would be very difficult to reset the switch. And when you're working with the hardware and with regular terminals, you're using print screen, and you will have to send a special break command. And you will have to use a special key in order to get to BIOS when booting and rebooting your computer. You may press Ctrl-B key. Thank you so much. This is what I wanted to tell you in brief, in a nutshell. Should you have any questions, you're most welcome. Thank you so much for your presentation. Look, there was the following question. Why still you opted for Perl? Just I like it. I know Perl better than anything else. It depends. I think that the question would be what can be done faster in order to do that quicker. Probably we will rewrite that. So there was an expertise, actually, and it was easier for you to do that in Perl. Tell us, is there any CI/CD infrastructure around that? How will the whole package be assembled? The system package? Well, you should have some systemic kernel, some packages. How do you build the whole system? Well, in that case, this is a kind of an operational system. And there is a BOR daemon, and there are no any objectives which have to be addressed from that. We're using a template. Okay. Just give me a minute. I will look into the chat. Probably we have some questions from there. No questions. Please join our chat. Should there be any questions, they will emerge there.